Hey students, this is lesson 523. In this lesson, we're going to learn how to multiply binomials that involve addition. We're going to use the idea of a rectangular diagram also to help you do that. So taking a look at the first problem here, we have the quantity x plus 3 times the quantity x plus 4. And we're also going to use the distributive property, but we're going to use a rectangular diagram to help us understand how the distributive property works here. So if we're going to multiply this, let's first draw a diagram here. And so we have x plus 3 for the width and x plus 4 for the length. Looks like that. And what I want you to think about here is, so if you remember, we'd have x squared here, 4x here, 3x here, and 3 times 4 is 12, right? So, but what I want you to think about is this. So here I have one rectangle that has a length or width of x and a length of, right here, x plus 4. So this rectangle right here can be represented by this expression. Now the other rectangle there, I'll highlight that in blue, this rectangle, can be represented by the expression 3 times the quantity. Remember, this is x and this is 4, so 3 times the quantity x plus 4. Then I need to add those two rectangles together. And so I'm going to do x times x, x times 4, 3 times x, and 3 times 4. And I'm just going to combine the 4x and the 3x to make 7x. And that's how you use the distributive property. So in the second problem here, we have k plus 5 squared. So a rectangular diagram for that would be actually a square. We have x plus 5 on both dimensions. Okay. So now I'm going to find the area of this rectangle right here, and that's x times quantity x plus 5. Then I'm going to find the area of this rectangle, and that's 5 times quantity x plus 5, and then I'm going to add the two together. So I have x times x is x squared, x times 5 is 5x, 5 times x is 5x, and 5 times 5 is 25. And then I'm just going to combine the two 5x's, make those 10x plus 25. All right, so that's using the distributive property. Notice that from my original expression right here, I'm multiplying x plus 3, and that x plus 3 is right here. And I'm multiplying each of those parts of this times x plus 4. So let's go ahead and try that again on the next page. Actually, we'll go to number 12 here. And on that one, so right now I'm on page 11. All right, it says consider the expression quantity p plus 3 times quantity p plus 5. It says use the distributive property to expand the expression. Now, so what I'm going to do is I'm going to take this p times this p plus 5, and that looks like this. And then I'm going to do this 3 times p plus 5 also. And so I get p squared plus 5p plus 3p plus 15. And then I'm just going to combine the 5p and 3p. And that makes 8p. Okay. Now it says draw a rectangular diagram to model that. And what I'm going to do is make one dimension p plus 5 and the other p plus 3. And so if I fill in all of these, p squared, 5p, 3p, and 15, what I have here is this rectangle is this expression, p times quantity p plus 5, and this rectangle is this expression, 3 times quantity p plus 5. All right, we're going to do one more problem here. So it says expand the following products of a trinomial and a binomial. It says you may find it helpful to use a rectangular diagram. I'm going to go ahead, we're going to use the distributive property here. What I'm going to do is take this x times x plus 1. Then I'm going to take this y times x plus 1. And then I'm going to take this 1 times x plus 1. And so I'm going to have 3 multiplications. First one in green is going to be x times quantity x plus 1. The second one is in red, y times quantity x plus 1. And the third one in blue is 1 times quantity x plus 1. And then I'm just going to add those 3 together. And that'll give me the whole expression I need. So using the distributive property, I get x squared plus x for the first multiplication. And then x times y, or y times x. And y times 1 is just y. And 1 times x is x, and 1 times 1 is 1. And now I'm going to look for any like terms that I can combine, and I can see that I have an x and an x there. So my final expression is x squared plus 2x plus xy plus y plus 1. All right, you can go ahead and try a couple of those, and the rest of them we will do the next time we meet in class.